Okay.
So are you guys looking at the homework assignment or the preparation assignment?
The preparation.
Preparation.
Okay. Make sure I have the right one here.
So
You're like, guess there's only two. I'm like, I must be opening the wrong one.
right. Yeah, if there was more than that, maybe it wasn't the right one. Okay.
That was the homework one, is why.
Right, that had more. Okay. I put my little guy with me so he couldn't scream and fight. So you might see him popping up in the background, but he should be quiet.
That's okay. That's okay.
Okay, so number 5, a four-sided die has 4 possible outcomes for each roll, 1, 2, 3, or 4. Calculate the mean of this discrete random variable. And so with this, obviously, kind of like they set up on our sample or on our reading, you know, each of them have 1/4 chance of gold. So 1 has 1/4 of a chance, 2 has 1/4, 3 has 1/4, and 4 has 1/4, which is either 1/4 or 0.25. And then would multiply the 1, 2, 3, 4 by the 0.25. And the sum I came up with that is 2.5.
For the mean?
Yes.
Yeah, that's what I got.
Okay. Oh, sorry, yeah.
The mean you got was 2.5? Okay, no, sorry. I was thinking of 2 point, yeah, sorry.
2.5, is that what you got?
No, that's what I was thinking you were saying.
Okay.
So for the standard deviation, that's what the next one is. I guess, yeah, I guess there are only two.
Oh, say, okay, yeah, so we're done with that. Is that it on that one?
Yeah.
Okay. I was like, it seems like there needs to be more on that.
I
That
know
one
the
seemed easy.
difference
I think
between
because
the
last
two
time we
is
went
just,
through everything.
right?
Yeah. I'm like, why was I complicating the homework if that's how easy it was? So, okay, so then the next one.
So I got for the standard deviation 1.29, or should it be 1.3? It doesn't say. It doesn't say which. It should be rounded to. So I think usually you round. You go to the second one after the decimal. Is that what everyone else got? Oh, there you are.
No, let me see.
Hello.
1.29?
I got.
I was more, I mean, like 1.2.
Okay, so the discrete random variable, let's see. I got 1.25, and then for the standard deviation, I got 1.118. What did I do? Okay, so
No, you sound right though. I mean, we're all right there.
So we need to, after we have the mean of 2.5, then we one, well, the number minus 2.5 squared, right?
Mm-hmm.
So 1 minus 2.5 equals negative 1.5 squared is
It's going to be 1.5 squared,
Yeah, negative 1.5 squared.
which is 2.25.
Which is 2.25. And then
Then you're going to times that by 2.5, right?
multiply that by 0.25, don't we?
Yes.
0.25. So 2.25 times 0.25 is 0.563 rounding up. Is that what you guys got
Yeah.
on the first one? And so then the next one, 2 minus 2.5.
What did you, hold on, sorry. What did you get on the last one? I got 0.5625.
Yeah.
Yes, but I
Just
think,
rounded it.
remember you always round up to the third.
To the third, so 5.63.
Right, there's only 3 spaces in as far as I understand. Yeah,
Okay.
5.63. So then I got, let's see, 2 minus 2.5 equals 0.5 squared is 0.25.
Okay.
And then if we, the square root, oh wait, no, we're not doing that yet, times, I'm getting ahead of myself, times 0.25 equals 0.0625. So we'd round it up to 0.063.
Which will be the same for the next one.
And the next one, right, is the same answer. And then number 4, I got the same as number 1, the 2.25.
Yep. So that'll give us the same answer with the 563.
So 0.563. So then we add all those together, 0.563 plus 0.063 plus 0.063 plus 0.563 equals 1.252, and so we just drop the 2.
So 1.25.
And
Okay.
then we need the square root of that.
Oh boy, I feel like I keep putting in the numbers wrong.
I do too.
Oh, I've done that so many times. I'm like, wait.
I'm like, there shouldn't be a large number on the other side of the decimal.
know.
I've still been there.
Let's see. Okay, so yeah. So 1.252, but then you round down, right? And then you do the
Right.
square root. Okay.
Right.
And do the 1118. Yep.
Right. 1.118.
Yep, you're right. You know, I
Is
must
that
have
right?
I must have just rounded differently to get the 1.2.
I must
Oh,
have
that could
too,
have
because
been.
that's what I got, was the 1.2 number. I don't remember what it was. What was it?
Oh.
Wait, pull it up.
1.29.
1.29, yeah. That's what I was saying before.
Okay.
So I don't know what I was, what did I round?
You were rounding up and I was rounding down.
And I did it probably 5 times, so I got the same answer each time, because believe me, they were different answers a lot of the time. I was like, okay, if I get it 3 times in a row, that's got to be it.
Oh dear. All right.
Okay, so I guess.
Now we just.
I guess, are we ready for the quiz?
No,
I'm a little nervous.
I don't even
I
see
know,
them.
because it took us 2 hours to get to this point last time.
Right, right.
And it only took us
I'm
15
like, I
minutes.
hope there's 2 simple questions on the quiz.
Okay, I'm going to keep this homework up. Okay. Okay, I think we are ready for the quiz.
Hey, you guys ready? Should we go?
Yeah.
Okay. Well, there's more than 2 questions.
Yeah. Dang it.
But the first 2, I guess, are easy.
Okay, hold on one second. Let me get to it. Okay.
Okay.
Ooh, 13 questions.
Woohoo!
Okay,
That gives ability of doing well.
that's true.
Then 2 questions. Okay. So number 3, I'll read over that and then we can work through it. So note, give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. Okay, human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States which each of these blood types is in the following table. Use the data to answer the following questions. The blood types and the proportions given in the table above define a probability distribution. Let's see.
I believe that's false.
Yeah, because it's
So,
0.45, 0.40. Let's see.
yeah, because that would equal more than 1,
Yep.
right?
Wait.
So,
But it doesn't, yeah, it won't equal 1. Wait,
right.
hold
It
on
will-
1 second. I think it might actually.
Yeah, it's just close.
No, it does. Sorry, it does
It
equal
does,
1.
yeah.
Oh, it does, right. Okay, so what are the other rules? Does it have to have all 3 rules? It's between 0 and 1, and the outcome will occur is 1, and then
Then the second one is a combination of the two.
is the 2,
Yeah,
right?
so if you add all of them up, then they equal 100, basically.
Oh, wait.
Can I ask you guys where you are
So
at?
it is
Huh? Aha, Minette! Yay!
Where's Minette? Hello.
Screen, but I kept clicking join, but no one was there. So I'm sorry, I'm late. That's weird.
We were just taking the quiz now.
Yeah, we just barely started.
Oh, have you guys been going for a while?
No,
No, it was
just
actually really
went
quick.
fast.
Oh my heavens, I'm so sorry. Okay, let me jump on. So sorry. I've been trying to get
You're
up.
fine. And there were only 2 questions
Yeah.
on the preparation assignment.
Oh, you're on the preparation assignment. Okay, I thought you were taking the quiz.
No, we're taking the quiz now.
taking
We
the quiz.
just barely did answer 1 though. Well, answer 3, but the first 2 you answer on your own.
Are you doing the homework or the preparation? Sorry.
We're doing the quiz.
The group quiz.
Yeah,
Yeah.
group meeting quiz.
Oh.
Okay, I'm going to read the rules so that we can kind of go over that one. And then, Minette, if you want to listen in. Are you on the quiz yet, Minette?
Not yet. Hold on. Just go ahead. Sorry.
We're just going over the rules of probability to see if it matches up with our answer.
Okay.
Okay, so the probability is a number between 0 and 1, which is true of all of them.
Mm-hmm.
And then the sum of the probabilities is 1. And then the probability of the outcome will not occur is -1, the probability that it will occur. Whatever that means. That's the one I'm always like, huh?
Oh, wait.
I know it's supposed to be a combination of the two, but It is true.
I would say it's true because they do total 1.
Yeah.
And it's between 0 and 1.
So the other one is basically you're minusing 1. It's almost like doing it backwards, I think. You're minusing 1 from the probability to see, again, if they add up.
Right, yeah.
Okay.
So do we need to worry about that for this?
No.
No.
So it's just true.
Yeah.
Yeah. It's just true.
One,
That's it.
I mean, because
Just move on. We figured it.
Minette, did you have any questions on probabilities?
Oh my heavens, I'm so lost on probability.
oh no.
I went to the tutoring session a little bit, and she kind of broke it down. She said that, because we were talking about standard deviation. And
So what we
go ahead.
was we added the sum of all the proportions together,
Okay.
and they equaled 1.
Okay.
So it's just asking us if the proportions given in this table above define a probability distribution. And we said true, and
0 and 1.
we just went over the rules, yeah, of why that would be true.
Oh, I see. Okay.
Okay, does that make sense?
Yes.
Of why we chose true? Okay. So, number 4.
Okay.
I can read that one.
Sure.
Okay.
What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places. So the probability that they have type O is 0.45.
Right.
That one's
0.45.
pretty, it's just right there.
Round to 2 decimal places. So
round to 2 decimal places.
we don't need to do anything on that then. We don't need to round up.
Yeah, and I think they just put that there so you didn't get rid of the 4 and say 0.5.
Got it. Got it. Okay.
So 0.45, right?
Yeah.
Okay.
So then 5 is, what is the probability that a randomly selected person will not have type O blood?
I got 0.55.
0.55? So
So did I.
you would take the 1 minus the 0.45, and it gives you 0.55.
Yeah.
So
Yeah.
I just add A, B, and AB together.
Oh, there you go. Yeah, all of those two, you can add them all together.
Right. Either way.
Okay. Minette, do you want to go ahead and read 6?
Bet. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowels contained urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from a bladder cancer patient? Round answer to 3 decimal places. So there's a 1 in 6 chance that the dog will be able to find bladder cancer specimen. Let's see.
Is it a 1 in 6 chance or a 1
of the
in
samples
7
came from the
chance?
person.
It would be a 1 in 7 chance.
Oh, sorry. One of the samples, there were 6 of the, 6 of the samples were from
So you guys froze. I'm not hearing.
Sorry, he has a 1 in 7 chance. So 1 divided by 7, is that how you figure it out?
Yeah, so it would be one
0.14.
0.14, and then you're rounding up, so then you're for 3.
3 decimal places.
Right? So 1.43.
Wait. Sorry. Say that again. How'd you get there? Let me follow you.
Okay, so it's 7, or 7,
7 bowls.
Yeah.
7 bowls.
bowls divided by 1, which gives you 0.14285 all the way down, but it's to round to 3 decimal places. So then would we round up? So it would be 0.143.
Because I got 0.14. I did get a 3. So did I do it wrong?
Let me double check mine again.
Wait, you
So
said 7
divided by 1.
Oh.
7 divided by 1?
Yes. Oh wait, sorry. Yeah.
Is 7.
1
Wait.
divided by 7. Sorry.
1 divided by
Oh!
7. So
Wait,
1/7. Yeah, that's why. So 1/7 of a chance. So 1 divided by 7.
Yes, okay, that's
I was confused
okay,
at first too
that's
because I was like, wait, that's not what I get for 7 divided by 1.
wow,
If
sorry.
we round the answer, we don't round up in this answer, do we? Or do we keep the 1.142?
Round answer to 3 decimal places.
3.
So we would round up, right?
Yes.
We would, yeah. It says round to 3 decimal places.
So it would be
Point
0.143.
143. Right.
Oh, I see.
Okay.
Okay.
Let's
When
try
I
the
get
next.
something that everybody else agrees on, I'm like, yes, okay. What is
Maybe
Okay,
I got
so
it right and my brain said it
if
backwards.
we all agree?
Yeah. Okay, so number 7, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patients 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there is little evidence that dogs can detect bladder cancer.
See the first one.
That they can because they selected it
22
22
times.
times.
Yeah. So if it was, yeah,
It's almost half.
because it's
Well,
only been a
here's the
14% chance.
I mean, it's a less than 50% chance.
it's less than 50% chance, so there's little evidence. That's what I would say.
Wait.
Because there's,
But then they add that part that it's very unlikely that the dog would do this well by random chance alone.
Oh, I see. Yes.
but did they just do that to throw us?
So 50.
That's kind of my thought process. If they hadn't thrown that in, I would say there's very little chance that the dogs can detect bladder cancer.
Well, because 32 of the times they did not detect it, but 22 they did. So 32 is more than 22.
So there were 27 times they did not detect.
So
Wait,
there's the
30
answer would
times
be
they
that
did not.
it's neither
Right?
of those answers. Because there is a chance that the dogs can detect bladder cancer. It's not a 50% chance, but
More like a
it's
40% chance.
more than random chance. So then would
So
that
does it provide strong evidence that they can detect?
Well, you know what?
that must be that not that they always detect bladder cancer, but it's possible for them to?
Is there a number that we go with for probability? Is it 0.006? No. Is that from the last lesson?
So I'm wondering, how would we set that up?
It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is appropriate?
Hmm.
You know what? If it was little chance, then I mean, kind of that last thing. I mean, 22 times.
Right.
That's not a fluke. I mean, little evidence tells me there's nothing. There's like it's only a minimal amount of times that they selected it.
Wait,
It's just a few
although
times.
Go ahead, Karina.
there is, so that one would infer that there is evidence. It's just a small amount instead of strong evidence that they can detect bladder cancer.
See, those words are confusing me there.
Yeah, they are.
Strong and little. I mean, it's
Strong
Did it say
evidence.
anything about that in the book
40%
at all?
chance. It's a 40% chance that they will detect it.
So 40% chance is good, but is it strong? But it's not little.
I don't know.
And we thought this would be easier.
I know.
Just because the wording.
I know, the wording is completely throwing me.
Do we see a way that we can work this into probability? Is there a way that we can take those numbers and plug them into what we know about probability?
Well, if we do, do we need to set it up 54 trials in order to do that?
With dogs?
I would say any trial that gives you a 40% return or a 40% positivity would be a strong evidence.
It's pretty
in support.
strong.
Yeah.
Okay.
Was there something from last week that said anything about that?
I'm trying to think. It seems like there was something about above a certain percentage is pretty strong evidence.
Yeah.
But of course,
It's
my
that
brain.
P number. The P number.
We're talking about urine. I'm sorry.
We are, actually, we are.
Yeah.
Okay.
But I was being serious, the P number. That's terrible, but like.
So are we all good with this provides strong evidence that the dogs can detect bladder?
How do you feel about that, Minette?
That's what I would have gone with.
Okay. Sorry, we're just talking through every possible.
But I do remember there being something, isn't
We're
there?
making it more complicated than it has to, probably.
I'm sorry.
Okay.
Sounds
Okay, so we're at the M&Ms.
Sounds much better than urine.
Yes, please. Okay, so M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. So you have 0.13 are brown, 0.14 are yellow, 0.13 are red, 0.24 are blue, 0.2 are orange. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Okay, well, are we supposed to fill in the green? Because the green is like blotted out for me.
Crossed out.
So,
Let's see, the next
number
question
9.
is green.
So would this
Yeah.
one just be the 13?
Well, that's why I'm wondering if we're supposed to add in that blue to even to.
Make sure that it, well, if it's
Okay.
not there, it would just equal 100 because we would make it.
yeah, from 100.
You know what? You're right. You're right, because that's the next question is answering the green.
Mm-hmm.
So 0.13 is the
That's what I would
probability.
say.
20 equals 85.
So then what is the probability that a randomly selected candy is green? Now it looked like you were writing those numbers out, Minette.
Yeah, I was trying to, that calculator wasn't working. It's set to a different thing. So I was trying to subtract the total of the brown, yellow, red, blue, orange from 100% to get the green.
Okay.
Does that make sense?
Yeah,
Yeah.
that's perfect.
I got 0.16.
Yeah, I got.
That's what I got. Mm-hmm. 0.16.
So the probability of drawing a red colored candy, 0.12.
No, number 8, the red candy was 0.13.
Yeah.
And number 9, the green candy is 0.16.
Perfect.
Did you get that, Minette?
Yep, that's what I got.
Okay.
Okay, so then the probability that a randomly selected candy is not green, I got 0.84.
Yep.
That's what I got.
Oh, I haven't gotten it. By just adding everything but the green together?
But the green, yeah.
But the green, yeah.
Or you could take the green and just subtract 1 and just take away the, is that the, oh, I'm sorry, that's what I did. Yeah, and I got 0.84. Okay, who wants to take 11?
I can.
Okay.
The ACT scores of students admitted to a medium-sized public university in the western United States was taken from CAPEX.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
So that's the median number, right?
Mm-hmm.
Median.
So 24?
Yeah.
So I think
It gives it right there.
Yeah.
Yeah, 24. I was going to sit and figure it out, but it tells me.
Yes, love it when they have that. We don't have to, so we are looking for the median in this and not the mean.
Okay.
Yes.
Okay.
Because
Awesome.
half the observations, right. Mm-hmm.
Because the median is 50%.
Mm-hmm.
Right.
Okay. And the 5 numbers. Okay. So based on the information on the table above, the top 25% of the students scored above what number? Would that be 27?
Top
That
25.
quartile 1 is 25%, right?
So
Yeah, so
that's the bottom 25.
isn't the bottom 25 22?
5 would be quartile 3.
Yeah. So I think it would be 27.
Yeah.
The top
Because that would be 75%. So that's
75%.
that's
So
the
that's
Q3.
Right,
And
which
so
is 27.
The top 25% scored above what number? So they would have the top 25% of the students would be between 23 and the maximum, or Q3 and the maximum.
Yeah.
So 27.
Yeah.
Ruth, you said it would be between the Q3 and the maximum?
Yeah, the top 25
Right.
students would fall between Q3 and the maximum. So Q3 is actually 75%, 75th percentile, and the maximum is 100. So you would look at the numbers that would be in between there. So if it's the top 25, you'd have to go from 27 up to 30.
35.
Okay.
So they scored above what number? So they scored above the 75th percentile, which is 27.
Yes. Okay, Cameron, do you want to take that last one for us?
Okay, sure. Which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will. A probability is a number between 0 and 1. The probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities is any probability is 1. So it's C.
It's C.
Yeah. Or the third one, whichever.
The one that
Yes.
doesn't make any sense.
The one that, yeah, exactly. That was just mumbo jumbo.
Okay, so I guess we need to just go back, double check, make sure all of them are in, and
We all completed.
yep.
And we'll see if those dogs got the best of us.
I know, right?
All right. We all
Okay.
ready?
Yep,
Okay,
let's
you
go.
guys ready?
Submit.
Okay.
Yay!
Yay! Good. Well, we figured out the urine.
Yes,
Hmm.
dogs can detect bladder cancer.
That is awesome.
Oh,
It helps to talk things out, though. You know,
It
it
does.
really does.
It does.
I was like, I wasn't sure there for a second. I got
It was a
good.
little worried on that.
Yeah, I do like that we kind of go through and look. What were you saying, Minette?
It's easy to talk yourself out of it and question your first
Yeah.
instinct.
Exactly.
Yeah.
Exactly.
Thank you, ladies.
Thank you.
Thank you.
That was like
Good
our
job.
fastest session ever.
Yeah, I am
Yay, that
loving.
was
I am
awesome.
loving our group. Thank you so much. You ladies
It
are
is
wonderful.
good. Thank you, guys.
Thank you.
That's awesome.
See
Hey,
you
we'll see you on Thursday. Yep.
Bye.
Yep. I'll send you an invite Thursday.
Okay.
Okay.
Awesome.
Thank you.
Bye.
Bye.
Bye.